For over 4 decades, Michael Jackson's dramatic physical transformation sparked worldwide speculation and controversy. Medical experts, geneticists, and the public questioned whether his changing appearance resulted from personal choice or legitimate medical condition. Today, breakthrough artificial intelligence analysis has finally provided definitive answers by processing vast amounts of genetic data, medical records, and scientific research that human analysis alone could never comprehensively evaluate. The revolution began when advanced AI systems gained the computational power to analyze the complete scientific landscape surrounding Michael Jackson's documented medical case. Machine learning algorithms processed over 790,000 individual genetic profiles from global genome-wide association studies. Cross-referencing this data with Jackson's official medical records, autopsy findings, and 3 decades of documented clinical progression. What artificial intelligence discovered represents the most comprehensive explanation of his transformation ever assembled. The AI analysis started with indisputable medical evidence. Dr. Christopher Rogers from the Los Angeles County Coroner's Office conducted Michael Jackson's autopsy in 2009, documenting focal skin depigmentation through histological examination. Artificial intelligence systems integrated this autopsy data with contemporary vitiligo research databases, immediately identifying Jackson's case as a textbook example of vitiligo universalis, the most severe form of the condition affecting more than 80% of total body surface area. Machine learning algorithms trained on massive genetic datasets identified the precise molecular mechanisms explaining Jackson's extensive transformation. AI systems analyzed 48 confirmed genetic loci associated with vitiligo susceptibility, discovering that specific combinations of variants create dramatically increased risk for severe presentations. The artificial intelligence pinpointed 3 critical genes in Jackson's documented case: TYR with an odds ratio of 2.5 for generalized vitiligo, PPN22 showing statistical significance of P less than 0.001 for severe progression, and NLRP1 affecting autoimmune inflammatory responses. Revolutionary AI-powered multi-omics analysis integrated data from FinGen, UK Biobank, and international research consortia, processing genetic information from nearly 800,000 individuals. These artificial intelligence systems identified 5 therapeutically targetable genes directly relevant to understanding Jackson's condition: YARBB3, RHOH, CDK10, MC1R, and DUFAF3. Machine learning models using these genetic signatures achieved diagnostic accuracy exceeding 98% with area under the curve values of 0.99, providing unprecedented precision in vitiligo classification. The AI breakthrough came when machine learning algorithms connected Jackson's documented timeline with molecular pathway analysis. Dr. Arnold Klein, Jackson's dermatologist for 25 years, had recorded the initial diagnosis in 1983 with formal confirmation in 1986. Artificial intelligence systems analyzed this progression data alongside contemporary understanding of the interferon gamma pathway, revealing how CD8 T cells producing interferon gamma activate JK-STAT, signaling cascades that perpetuate autoimmune melanocyte destruction. Deep learning networks employing convolutional neural architectures achieved remarkable diagnostic capabilities when analyzing Jackson's photographic documentation. AI systems using efficient NetB7, ResNet, and SWIN transformer models demonstrated over 90% accuracy in vitiligo detection, far exceeding human dermatologist performance. When these artificial intelligence systems processed 3 decades of Jackson's visual transformation, they confirmed progression patterns perfectly consistent with severe autoimmune vitiligo development. Artificial intelligence analysis explained the critical role of the Koebner phenomenon in Jackson's case. Machine learning algorithms processing trauma response data identified how the 1984 Pepsi commercial burn activated dormant autoimmune processes in genetically susceptible individuals. AI systems revealed that thermal injury triggers specific molecular cascades in carriers of vitiligo susceptibility variants, explaining the documented acceleration of Jackson's transformation following this traumatic event. Predictive AI models trained on biomarker data achieved extraordinary accuracy in forecasting vitiligo progression. Artificial intelligence systems identified CXCL10 as the most effective predictor with area under the curve of 0.896, while interferon gamma emerged as an independent predictor with odds ratio of 1.051. When AI algorithms applied these biomarker signatures to Jackson's documented clinical course, they retroactively confirmed his genetic predisposition to extensive vitiligo development. Machine learning analysis of family genetic patterns provided crucial insights into Jackson's hereditary susceptibility. AI systems processing population genetics data revealed that approximately 20% of vitiligo patients have affected first-degree relatives, with 7 to 10-fold increased familial risk. Artificial intelligence connected Jackson's sister LaToya's public acknowledgement of family vitiligo history with contemporary genetic inheritance models, validating the hereditary component of his condition. AI-powered pharmaceutical analysis revealed the medical legitimacy of Jackson's treatments. Machine learning algorithms processing drug databases confirmed that the 19 tubes of hydroquinone and 18 tubes of Binikin found at Jackson's residence represent standard medical therapy. Artificial intelligence systems verified that monobenzone, Binikin's active ingredient, remains the only FDA-approved depigmentation agent specifically indicated for vitiligo affecting more than 50% of body surface area. Advanced AI diagnostic systems now provide objective assessment capabilities that definitively characterize vitiligo severity. Automated algorithms calculate vitiligo area scoring index measurements with 92.91% sensitivity and 0.79 jacket index accuracy. These artificial intelligence systems eliminate human observer bias and provide standardized evaluation protocols that confirm Jackson's case represents legitimate autoimmune disease progression rather than cosmetic manipulation. Artificial intelligence analysis of population genetics revealed specific variants affecting melanin production in individuals of African ancestry. Machine learning algorithms processing over 2,000 African genomes identified the MFSD12 gene as crucial for understanding pigmentation differences. AI systems discovered that variants in this gene create dramatic visual contrast when vitiligo develops in individuals of African descent, explaining the striking appearance changes documented in Jackson's case. Contemporary AI-guided drug development has produced breakthrough treatments targeting the exact molecular pathways identified in Jackson's condition. Machine learning algorithms design JK inhibitor medications that specifically block the interferon gamma signaling cascades driving vitiligo progression. Ruxolitinib, developed through AI-assisted pharmaceutical research and approved by the FDA in 2022, demonstrated 50.3% efficacy in Phase 3 trials involving 674 patients. The artificial intelligence analysis extended to comprehensive literature review, processing thousands of peer-reviewed publications to establish Jackson's case within the broader scientific context. Machine learning systems identified the study published in the Journal of Clinical and Aesthetic Dermatology documenting the Michael Jackson and Winnie Harlow effect, which confirmed Jackson's autopsy validation of vitiligo diagnosis and established June 25 as World Vitiligo Day in recognition of his contribution to medical awareness. AI-powered statistical modeling achieved remarkable predictive accuracy for vitiligo progression patterns. Machine learning algorithms developed through multi-institutional collaboration demonstrate 90.5% accuracy in training datasets and 88.9% accuracy in independent validation studies. When artificial intelligence applied these predictive models to Jackson's documented timeline, they confirmed his transformation followed established autoimmune disease progression patterns with mathematical precision. The comprehensive AI analysis has definitively resolved decades of speculation about Michael Jackson's transformation. Artificial intelligence systems processing vast datasets encompassing autopsy findings, genetic research, biomarker studies, family history, treatment records, and diagnostic imaging have reached an unambiguous conclusion. Jackson's physical changes resulted from complex genetic susceptibility interacting with environmental triggers to produce extensive autoimmune melanocyte destruction, not voluntary cosmetic alteration. This breakthrough demonstrates how artificial intelligence can solve complex medical mysteries by integrating and analyzing data volumes far exceeding human analytical capabilities. Machine learning algorithms have provided the computational power necessary to definitively characterize Jackson's condition through evidence-based analysis spanning genetics, immunology, dermatology, and pharmacology. The AI analysis has transformed a decades-old controversy into a well-understood example of severe autoimmune disease progression, offering valuable insights for advancing vitiligo research and treatment development worldwide.